次の講演は Operation I am Tom 企業ネットワークにおいて APT アクターがその内部で移動する方法についてです。講演者はアラゴルンツェンさんとチャールズ・リーさんにお話しいただきます。Team T5 は持続的標的型攻撃 APT に強い企業です。彼らがさまざまなクライアントに接して見えてくる攻撃者を知らないがゆえの未熟な作業が原因でかえって脅威主体が動き回るのに都合のいい移動手段になっている事例も多いと言います。Our next session is Operation I am Tom. How APT actors move laterally in corporate networks. Please welcome our speakers. Argon Chen, Charles Lee. Please start.
Okay. Hello, everyone. This is Team T5's talk in Coblue. The topic today is how APT actors move laterally in corporate network. It's related to an operation we called I'm Tom. The agenda today, the first part, introduction. The second part, we will introduce you some interesting ID phones penetration techniques. The third part is our discoveries in this operation related to Webshell abuse. The last part is some miscellaneous techniques. And I'm Charles Lee, the CTO as well as Chief Analyst of Team T5.
And I'm Argon Chen. I'm a malware researcher at Team T5.
So before start of this talk, I would like you to know why we call it Operation I'm Tom. So it was in an incident response cases a few months ago. Tom is a incident response people in Team T5. He was fighting hard with bad guys in one of our client network. For months of fighting, he discovered some message left by the threat actor in a TXT file, and the file name is imtom.txt. Yeah, that's the most interesting part of fighting with APT actors. Most APT attacks are done by humans. So whenever they discovered your investigation, your analysis actions, they will try to find a way to bypass or hinder your analysis. In the corpus of months of fighting with bad guys, they tried various means to stop our investigation. As we show in the photo, we stop their activity, and finally we get them rid of our client's network. After that, we decided to compile all the techniques they used in this attack, and they become the materials of this attack. So this talk will cover some post-exploitation techniques used in corporate network. Their purpose is either doing lateral movement or bypass detection or threat analysis. They are mostly observed in real incident response cases, which is Operation I'm Tom. And they are leveraged by various Chinese threat actors, and they are widely discussed in some Chinese forums. So in the next session, I'm going to introduce you several techniques that is popular in AD phones penetration. Before diving into each technique, let's have an overview of Windows AD authentication mechanism. The left part, LSA, stands for Local Security Authority. Is the core component of this mechanism. On top of it, there are several protocols such as NT SSP, Kerberos, etc. Microsoft prepared different library for each of them. All of them follow the SSPI, which stands for Security Support Provider Interface. If you follow the interface, you can have your application to communicate with underlying protocol. Here, I would like to introduce you another great tool. The name is Mimikatz. I believe most of you have heard of it. It has a library called Mimilib, which has most of the credential dump techniques implemented inside, and most of the techniques in this chapter is implemented inside. Mimilib itself can be used to dump credential. In order to do that, the action is simple. Just copy mimilib.dll to Windows system directory, and you just modify the following registry key. After that, you just reboot your computer and log in. You will find a file kiwi.ssp.log being generated in the system directory. In the log file, you will find the logged credential. In order to detect if you are an incident response people and you want to detect this attack, you can check the above mentioned registry key to check if there is some suspicious library being added. Or you can also check the process memory of lsass.exe to see if there is some suspicious library being loaded inside. Mimilib also supports another kind of attack. The name is Memory SSP. It's an memory injection technique. To do that, you just run Mimikatz and type the following command. And Mimikatz will inject a shellcode into the process memory of lsass.exe. After that, once someone log in, you will find a log file, mimi.lsa.log, being generated in system directory. In the log file, you will find a logged credential, as shown in the photo. If you further trace the memory status before and after the patch, you will find that Mimikatz tried to hijack the workflow to redirect it to the injected shellcode. If you want to detect this attack, you can try to check the process memory of lsass.exe. You will find some memory block with rewrite executable block that has strings of Mimikatz inside. The third technique is called skeleton key attack. This technique was first uncovered by Dell SecureWorks in 2015, and it supports from Windows Server 2003 to Windows Server 2012. This attack will inject some shellcode into the process memory of lsass.exe to change its authentication flow. After this attack, all the domain user account can be logged in with an inserted master password to log into the AD domain. At the same time, all users' original credential can still work unaffected. Note that because the attack relies on memory patch, it will fail after system reboot. If you want to try this attack, you can just run Mimikatz and type the following command. After that, some shellcode will be injected into the process memory of lsass.exe. And if the action succeeds, you can just use the password Mimikatz with any existing AD accounts to log in. The photo shows the effect of this attack. The left photo before this attack, if you don't know the account's password, you cannot log into this AD. However, after this attack, you can use the password Mimikatz combined with any existing AD account to do login. If you further trace the injected shellcode, you will find a block that concatenates some hash value. The hash value is just the NTLM hash of the string Mimikatz. If you want to detect this type of attack, first you can still check the process memory of lsass.exe since it still relies on memory injection. Or you can also check Windows event log. as I mentioned, this attack failed after system reboot. So the related malware usually registers itself as some system service. So the following system log combination is related some secure privilege service being executed. Then you can check to find a related attack. The next technique is called Wdigest. Wdigest is an Windows authentication mechanism. It caches clear text passwords in memory for later authentication actions. This feature was abused by various threat actors to dump clear text password from memory directly in the past. Microsoft noticed this issue, so they issued the security patch KB2A71997 to disable this feature. After the security patch, you can set the following registry key to disable this feature. The following photo shows the effect of this registry key in different Windows platforms. The photo shows the effect of this attack. The left photo, before applying this security patch, you can see clear text credential in memory. After applying the security patch, you can no longer see the locked cached credential anymore. In the Operation I, the actor relied this attack several times, and we detect and block their actions. In the end, the actor got angry, so they used some group policy to disable us from access the above mentioned registry key in an attempt to stop us from disabling this feature. If you want to detect this attack, you can check the following event log ID. For in a domain controller, you can check event ID 4776 that is related to Wdigest authentication package. Or in every server in this AD domain, you can check event ID 4624 that is related to Wdigest. In the Operation I, the threat actors used Mimikatz a lot and got detected by us. So they tried different means to bypass the detection. For example, they apply some re and protect packer or forfeit as some security scanner product. In the end, we realized that all the techniques they utilized was discussed widely in some Chinese hacking forums. The last attack is called ntds.dit. In a standalone Windows host, the Windows password is stored being after hash in the following registry keys. In the AD domain case, password is stored in the system directory, ntds.dit file, and the HKLM system registry. If you want to dump the hash value, you can take a snapshot of the file by using ntds utility. And after that, you can copy the ntds.dit file and the registry key HKLM system. After that, you can use ntds dump ex tool to get all users' password hashes. If you want to detect this attack, you can check the following Windows event log, because dumping the taking snapshot will cause volume shadow copy service, and the following event log is related to this service. So to summarize this section, remember to remove our limited access to Windows Share. Also disable the remote registry service. And since most attacks is abusing zero injection, remember to limit your user account to have the SE debug privilege. and protect the LSA's memory process well. Last, in protect user group, if NTLM is not used, remember to use Kerberos or third-party SSP and have your Kerberos ticket have a shorter lifespan as possible. Last, don't cache your Windows digest.
And next part, we'll go to application level host. In application level host, actors usually use Webshell to conduct the lateral movement. First, I will introduce the IIS module. A native IIS module is a Windows DL file that can extend the IIS and for some desired functionalities. The first IIS module abuse was found in 2018. IIS module Backdoor, RGDoor, called RGDoor, used by APT 34. And we saw many actors abuse this IIS module to conduct some particular function of them. And the IIS module process is under the w3wp.exe. And there is an open source POC project of the IIS Backdoor called IIS Raid. It can be easy to install via app-cmd. IIS Raid can not only execute command, but also can inject shellcode or extract password from the web. And if you install the IIS Raid, you can use app-cmd in command line or use IIS Manager in GUI mode to list IIS module in your server. And if you use the IIS Manager, you can see the suit path in the GUI mode of the DL file. And if you run some system command by the IIS Raid, you can see your command in the traffic in Xcron variations, and you can see your password in Xpassword section. We also see some actors use base64 to encode their command in the traffic. And here is some precautions for IIS module attack. First, you can use app-cmd command line tool and also use IIS Manager to list your module in your IIS server. And second, you can search for the existence of Xpassword or Xcron variations headers in your traffic. And here is the thing that everyone often ignores. The default privilege in Exchange server is local system. So if the actor can access your Exchange server, they can do everything they want. And from this picture, we can see that the default permission in IIS is the app pool, and in Exchange server is system. So if the Webshell or the malware is located in the Exchange server, an actor can use them very smoothly and can make their attack more easily. And here we want to share a modified source code Webshell attack target on the Exchange system from one of our clients. The Exchange system is for single sign-on, and the actor didn't put any malware or Webshell in the server. They just modify some existing files source code to concatenate them to achieve the function of the Webshell. The picture of the left side is the source code of the JavaScript of the logan.spx. And the picture on the right is the modified code. We can see the code can log username and password and post them to one HTTP server and arrowfe.spx. And the picture on the left side is the source code of the arrowfe.spx. And the right side is the modified code. The modified code is the HyperShell. The HyperShell, the modified code is to log username and password to save them to the debug directory. And actor can log most users' password and username in plain text, and then they can use the password to log on the organization's VPN, and they can use their internal system. And this part, we're going to introduce the HyperShell. HyperShell is also a modified source code shellcode. It adds the malicious code into expire password.spx, which is resetting the password in Exchange system. And this tool was first used by APT 34, but it leaked on Telegram on 2018. And the picture on the left side is the source code of the expired password.spx, and the right side is the HyperShell. The HyperShell is a complete function web shell, and you can just use curl and username and password and connect it. And here is some precautions for the modified source attack. First, you can modify the directory permissions, or you can use some file check technique like some file numbers or file hash. Microsoft also have a tool called File Checksum Integrity Verifier. It can help us to check the MD file of all files in one folder to check if there any files have been modified. And there is a mechanism that can help us for incident response with the Webshell. And when an XPX file was first accessed, the cxc.exe will compile it and will generate a compiled DL cache file in the temporary folder. So if we want to know when is the Webshell firstly accessed, we can see the file create time of the compiled DL cache file. And along with the IIS log, we may figure out how actor put the Webshell. And Microsoft have some antivirus whitelist suggested on Exchange server, and you can see the whole list on their website. The actor can take advantage of these suggestions and make their attack easier. The whitelist include mailbox servers, client access servers like web components. We think the actor knew it, so we found they often put their web shell or malware in these whitelist directories. So we suggest that you can check this whitelist folder first during the incident response. So this is the register for the antivirus whitelist setting. And we can see the no scan directory include the web components. The deserialization attack was a trump card for APT groups in this year. As long as the CB 2020-0688, there are many deserialization attacks on .NET can be used. And today we are going to share the deserialization attack on .NET Viewstate. .NET Viewstate is an object passed between client and server that store both user submit and application info. It is protected by HMAC and is serialized by loss formatter and deserialized by object formatter. Open source tool whitesource serial.net supports object state formatter. A machine key is a key component for the Viewstate. And in low balance environment, the machine key may be auto-generated and hard-coded in IIS pool. And the machine key is stored in the file web.config file. So in some consequence, if you got a web config file in the wild, like some outsourced software vendor can accidentally put their framework on GitHub, an actor can use this web config to generate a malicious payload. And here's the exploitation path. First, you must get a machine key, and you can use Serialization.net to generate a malicious payload and submit payload as a Viewstate, and server will validate the HMAC and deserialize the malicious payload. And the picture on the upside, you can see the deserialization attack in the burst suite. It will generate a post request, and the payload will send us a Viewstate. And the picture on the below is the IIS log from one victim host. You can see it will just post with a slash. It cannot give us more information. So I spent about 2 hours to identify this deserialization attacks in the first incident. And here's the precautions of the deserialization attack. Please review your open source projects for default keys. And if your web server is ever compromised or has a file read and data flow, please regenerate your keys to set to auto-generate. Or if possible, encrypt the machine key. And last, we will introduce a web-based malware called TB-Shell. TB-Shell is a backdoor based on HTTP API. After it is executed, it will use Windows HTTP Server API to open an HTTP server service and register a specific URL for actor to control. It is a backdoor for listen, poll, and complete function. TB-Shell often use the hijack technique and inject the payload to process and register a specific URL for actor to access the TB-Shell controller victim host. TB-Shell is constantly evolving. Recently, we observed TB-Shell 3.0 version. And last part, we will share some miscellaneous techniques by the actor. In lateral movement, there is a trivial but effective technique. It's called sticky backdoor. It can be triggered by press the shift 5 times. In operation time, we find the sticky backdoor on almost Windows host. Because the backdoor is not a real malware, so the antivirus software may not be alerted by this attack. And here we want to share a Kaizo trap by the actor. In observation time, we can see actor access the Webshell, and we can see the delete record of the Webshell in the event log. And the routine latest 2 or 3 times. But one day we can only see actor access the Webshell, but we can see the delete record in the event log. At first, we think the Webshell may be deleted, but we still feel strange. So we conduct a more in-depth investigation, and thus we found the Kaizo trap. The actor used the rootkit called the easy file locker to hide the folder of the Webshell, so we can see any file in the under this folder. The picture on the left and up is the component of the easy file locker, and the picture on the right is the driver of the easy file locker in Registry. The easy file locker is a benign tool to connect folders and files if it is used properly, and it only have a 1 detection rate in virus total, so it is hard to detect. And finally, we want to share a mechanism that actor will take advantage of. If you use appcmd to save virtual directory, and you can access the file, just use the file path as a URL in your browser. So in this attack, actor do not need to install any malware or hacking tools. he can access the files. Just use this technique. And here's our conclusions. Active Directory attack is an indispensable part of lateral movement. We must pay attention to preventing AD front attack. In lateral movement, actors use less malware. They begin to use some legal tools or abuse the original Windows mechanism to achieve their goals. And here is our talk today. Thank you, everyone.